Okay, this is an example of one of the planning questions, okay, from Serangoon Secondary School 2018 prelims. Okay, so what you have here is an equation. Okay, it comes from an earlier experiment, okay, which is on measuring resistance and potential difference and length. Okay, so now the equation that they gave earlier is written in this form. Okay, so we need to do planning on this question. Okay, to try and get 5 marks. So your plan needs to include list the quantities that remain constant, okay, the control variables, description of how you perform the experiment, which means the procedures, the graph, and an explanation of how rho can be found from the graph. So for this case, it is quite obvious that what will change, okay, for the experiment that is done earlier, okay, it may not be clear in this question here, but for the experiment, what will change is the value of L and the value of V. Okay, so for this particular case, as you do the experiment earlier, you'll realize that the independent variable, as you write, in the independent variable, it will be the length, because you can vary the length to vary the potential difference. The dependent variable will be the potential difference. Of course, you see what I write here is in terms of the letters given here. Okay, your control variables or constants, depending on question, okay, sometimes you can actually take from the equation here. So in this case, A, the cross-sectional area of the wire, and I, the current passing through the wire. Okay, this is an experiment on electricity, on circuits. So now that I have defined my independent, dependent, and constants, okay, the next one will be on the procedures, the description of how you would perform the experiment. Okay, so remember procedures. Step 1 is how to measure your independent, step 2 is how to measure your dependent, and step 3 is how to vary your independent. So how do we measure the independent? So step 1, first we can say that set up the circuit as in the earlier figure. Okay, so usually there is earlier figure that's given, so you write as in the earlier figure. Step 2, we can, in this particular experiment, we can let L, because in this experiment, L is set by the person doing the experiment. Okay, sometimes you may need to measure instead of setting it. Okay, so let L equals 50 cm. This is just an example, may not be. For different experiments, the values can be different, so use your own judgment on these values. Okay, so let L equals to 50 cm. Okay, this is measured by a meter rule already. So step 3, record or measure V using a voltmeter. Okay, so it's record or measure what variable using the instrument or equipment. Okay, so now you have your independent variable here, you have your dependent variable. So you need to vary this. Okay, the trick to writing the vary is to use the word called repeat. For this case, it's quite simple. Repeat. See, repeat. Steps 2 and 3. Okay. For L equals 40 cm, 45 cm, 55, 60, 65 cm. Okay, what happened here is that I'm trying to have 6 different values and listing out the values. Okay, there's 50 cm here, so I have another 5 more years. Okay, so repeat these 2 steps for these values of L. That's what this step means. We repeat the steps. So now our experiment procedures are done. This part is the procedures. We're going to go on to your step 5, which is what I will call analysis. So for L equals to V A over rho I. Now we know that this is the independent, this is the dependent. Okay, normally we want something like dependent equals something times independent. It's like y equals mx plus c. Okay, it's like this one is a side working for you. Something like y equals mx plus c. This is the dependent, this is the independent. So normally we will plot y versus x. Okay, so that's what we want to achieve here. So now we want to make v, which is the dependent, the subject. So we can see that v is equals to rho I over A times L. So now this is the dependent, this is the independent. Plot V versus L. Okay, plot the dependent versus the independent. So after that you state that your gradient is rho I over A. There is no y-intercept because it passes through the origin. Or you say the y-intercept is 0. Okay. So finally, we need to explain, we need to answer the question. Okay, this is a statement of the graph that you plot to test the relationship. So finally, is an explanation of how rho can be found from the graph. So you can see the gradient and rho is here. So the last part, rho can be found by, now I write the equation, rho equals gradient times A over I. So that is how you do your planning. So how will the marks be allocated for this particular case? Okay, my suggestion is that, or in my opinion, okay, there will be 1 mark for this. There will be about 2 marks for your procedure, 1 mark for your graph, and 1 mark for answering this. So total of 5 marks.